Okay, E4 steel. Layout is the same as with all of this material, lecture, subtraction, properties, acquisition, design consideration, and applications. And introduction. Steel is a super strong material. It can deal with high tensile as well as compressive strength. That's nice. It's a ductile material which has this plastic state, which means it doesn't break by bang an impulse, but it say slowly extends its dimension, and by that allows us to deal different with forces within the material. It can be used for a very say small and narrow forces transport. That makes it a super interesting material, which we see in the numbers. The compressive strength, the tensile strength, Young's module as well. But it also has a very good thermal conductivity, which means it transports energy very well, which is something which in facades we may do not like, as we like to secure that there's a certain insulation layer of the material itself. It has a high density, so a lot of weight, a lot of load is applied by the material itself, which means solid structures out of steel are not that common because it's such a strong material. It doesn't make sense, and it will bring so much loads by its well. It's two ways of the main acquisition of the material. It's the iron, the coal being fired in an oven, 1600 degree, and then this whole melt is brought into a molding process, and it's either within this hot process or within a cold process being then processed to be the material which we use in our facade constructions. This hot process means 1600 degree then is brought into in a die, and by that die it actually creates this outer line, and that's serious. This die really is it's casting into this die, and the inner part of this rope is still liquid while the outer part already cools, and then this whole thing is cooled and then brought into this hot rolling devices, which then compact the material as a first acquisition process. What happens there is the material itself gets as from say certain grain structure, and when then being compacted, this material is the structure of the material itself is compacted, and by that creates a higher strength of the material as a system versus the so-called cold rolling system, which is the bottom part. This part, a cold rolling system, means the material itself is not in an still liquid and hot status, but it's really cold, so it can be done later as well. And then by being cold rolled, it's compact again to compact the material to shape it, but also reinforce it by its strength. And then in the last step, it's obviously cut and then being made ready for transport as a system. This is the way how it is transported. It's either a steel coil, which is some kind of unlimited rope of thin steel, or it's steel plates, as we see that here, which are then chopped and cut after the production process. These coils, that's what we mainly use in our facade environment. They're brought into a position to go from cold folding, cold forming process. We see that in a minute. Super interesting process to create such products. So if you see some kind of products like this, which we use very frequent in facade constructions, for example, as a stick system, this is so-called cold formed plate, and it's made out of these coils as we see them here. They're brought in position, so the coil is brought in position. That's what happens here, and then it's brought into this main line being positioned correctly, and then we see all these dies, these rolls to form the metal. And when we continue, we see they change their shape, and there's another negative roll at this part, and this whole thing changes the shape of these of the metal itself. It already gets into a certain angle, and if you continue that process, it ends up in a certain shape, which is then, for example, this U-shaped profile, which we just saw at the beginning, to be done. And you can imagine if you have a flat piece and that needs to be folded in a way, you need to make sure that you're actually following the right order to fold it to that shape you like to have it, and you can't refold something later. So also the geometry of the profile is something which is linked to that. We see that happening, we see that being continuing, and then it ends up in this U-shaped profile. This is a U-shaped profile which we then have as a result, and then it's cut with this guillotine clock every 6 meters to have then the profiles as we want them. This is this whole set as it is done in manufacturing. If we want to have holes, if you want to get holes being punched into the metal, that could be done with these devices. So we have a certain geometry which defines the holes being punched into the sheet metal to create the openings where we want them, or we actually drill them as an alternative setup. So that's this process, how they are in general made. Alternatively, if you want to get a steel bar, which is very, say, sharp, or sharp edged, or we need to create a steel bar which has a certain geometry which we can't fold as a system. This could be done by welding. So you actually have these the steel components being brought in position, and then, for example, this welding robot then creates this shape. This could be done with I sections or T sections or whatever kind of geometry. This could also be done with tubes. So this is the coil, then ending up the cold rolling divisions to create the tube itself, and then the welding process where the tube as well, the final outer line is brought into position. Design consideration, steel is corroding, so we need to protect it. This protection is either done with some coatings or coverings. It could be a plastic covering, could be in a paint, a coating, or it could be this galvanization of steel, which is in a zinc surface, which is then brought on top of the steel to prevent any corrosion, or alternatively, more expensive, you go for a stainless steel, so a different aggregated stainless steel material to be used, which is then not corroding as the material itself. And by that, I stop this lecture.